Okay, welcome. This is a lesson to help you get familiar with vectors and scalars and to understand the difference between distance and displacement. And what you see on the board are four different diagrams of baseball diamonds that we're going to use as an example. If you run the base after hitting a single, after hitting a double, a triple, or a home run. Now, a baseball diamond is actually a square. It has 90-degree angles at every base, four 90-degree angles, and each base is 90 feet long. So, if you hit a single, you run from home plate to first base. Let's mark this as first base. And if you run that distance, you travel 90 feet. Now, if you ask the question, what is your displacement, which I'll denote as the D with a little vector symbol above it, which is your change in position or your change in distance from where you started to where you ended, you can draw that as a vector, which looks like a ray, which starts at a starting position, the tail of the vector, and the tip of the vector you draw with an arrow. And if you draw that vector, that's your vector representation. It shows the direction you traveled as you went 90 feet. So you went 90 feet in this direction from home plate to first base, and your displacement is also 90 feet. It just includes the direction. The difference between distance and displacement: distance is a scalar quantity. It's just a number that has magnitude only. Displacement is a vector quantity, which includes the distance you traveled in the direction you travel. So you draw this symbol with an arrow denoting the direction. Often distance and displacement are the same. They're both 90 feet in this case because you didn't have any change in direction. You traveled 90 feet distance and you ended 90 feet away from where you started. But that's not the case if you hit a double or a triple or a home run. It's a little different. So let's examine those cases. Now let's say you hit a double. You run from home plate to first base 90 feet, and then you run from first base to second base another 90 feet. So you can see the distance traveled is 180 feet. Ignore direction. You're just concerned about the quantity of total distance traveled, 180 feet. But if you ask the question, well, what's your displacement? Now you're asking a question, how far are you when you finish running to second base compared to where you started? Now, if you started at home plate and you ended at second base, the way you would analyze that distance is you would draw a vector from the starting point to the end point, and the length of this vector is your displacement. Now, to consider how long that vector is, how long is it from home plate to second plate? Well, you can use the Pythagorean theorem because the length of each of these sides is 90 feet. And if you recall your Pythagorean theorem, the length of a hypotenuse of a right triangle, if you see that, the hypotenuse is your displacement vector, the two legs of the right triangle are 90 feet long, then you can make the argument that the displacement vector, that's your hypotenuse squared, equals 90 squared plus 90 squared. And if you solve that, 90 squared plus 90 squared, then take the square root of both sides, you will get about 127 feet. So now, if you look at the difference between your distance traveled and your displacement, they're very different. You traveled 180 feet total distance, but you have been displaced only 127 feet from where you started in this direction. So it includes the vector showing the direction from where you ended compared to where you started. Consider a triple, slightly simpler case. Distance, you travel 90 feet plus 90 feet plus 90 feet. You get to third base on your triple, so your total distance becomes 90 plus 90 plus 90, which is 270 feet traveled. However, your displacement, very different. Now you have to ask yourself, where did you start at home plate? Where did you end at third base? What is the difference between those two positions? Well, you could draw that as a vector, which I will do here. It includes the direction from where you started to where you ended. You can label that with your displacement vector. And clearly, it's just the distance between home plate and third base, which is 90 feet. The distance between every base is 90 feet in baseball. And we've drawn it with direction. So you've traveled 270 feet around to third base on your triple, but you've only been displaced 90 feet from home plate compared to where you started. Home run, simplest case. You travel 90 feet around all four bases, and therefore you have traveled a total distance of 360 feet. However, you started at home plate, you ended at home plate, so your displacement is 0 feet. You have not been displaced. You ended where you started. There is no vector, no arrow to be drawn because the length of it is 0. Please reference this again and again for extra help and try the sample problems your teacher has prepared for you.